So we'll discuss these two questions today. The first question says that a particle is vertically projected upwards with a certain speed from the top of a tower, reaches ground in time t1. If it is projected vertically downward from same point with same speed, it reaches ground in time t2. We have to find time required to reach ground if it is released from the rest from top of the tower. So if it is released from raised from top of the tower, we have to find out the time. So these are the options given. The first question says that a particle is vertically projected upwards with a certain speed from the top of a tower. So let us assume that there is a tower here and the height of this tower is h. It is not given in the problem, it is my assumption. And that a ball is projected upward from here, from the topmost point of the tower, a ball is projected upward. The time taken by this ball to reach the ground is t1. So time taken by this ball to reach the ground is t1. And now on the same tower, from the top, a ball is projected vertically downward with the same velocity. The same ball is now projected vertically downward, and in this case, the ball takes time t2 to reach the ground. So what you have to find out is that now the ball is released from the top of the tower from rest, how long this ball is going to hit the ground. We have to find out this time. So let us call this time as capital T, and the question is capital T equal to question mark. So how to do that? Okay. So first let us try to form the equation for these two situations. So for the first situation, the ball is projected vertically upward with velocity u. Okay. So the theory says that from wherever you throw the ball, whatever be your point of projection, you have to take the origin at that point. So your origin is at the topmost point. When it reaches the ground, it reaches, let us say, point A, the bottommost point of the tower. So what is the vector? What is the displacement of this ball? The ball was initially at O and finally is at A. So the displacement is OA bar, right? Origin here, terminus here. So what is the displacement? The displacement S is equal to minus h. What should be the equation for this? So with velocity u, taken time t1, so the equation is S equal to ut plus half at square. Now because throughout the motion, the gravitational field or acceleration due to gravity acts vertically downward, that means I can write minus h is equal to ut1 minus half gt1 square. Remember why I have taken here negative sign? Because the gravity acts vertically downward. Now in the second case it is the same h and from the top of the tower, so the origin is here and the ball comes downward. So what is the displacement now? It is minus h. So s is minus h. Ball is thrown vertically downward, so what should be the sign of u? It must be minus u. And what is the time taken in this case? It is t2. So minus u t2. Gravity is again vertically downward, so it is minus half g t2 square. So this is equation 2. You can cancel the minus sign and you get an equation which is h equal to u t2 plus half g t2 square. Negative sign taken out from both sides, LHS as well as RHS. So this is equation 1, this is equation 2. Now for the last case, for this capital T. Now your u is 0, the ball again goes downward, so this means it is minus h, and gravity again is acting vertically downward, so that means g is negative. So what should be the equation? So let me just erase this part and then form the equation. So for the last part, your h is again negative, so minus h, u is 0, gravity is vertically downward, so minus half g t square, cancel the negative sign, you get the equation h equal to half g t square. So this is the equation 3. Equation 1, equation 2, equation 3. So this is where physics ends. So first please check whether have you understood the formation of the equation. I am assuming that you have understood the formation of the equation. Now it is just plain algebra, simple algebra. So how to solve this? Our target is capital T. So what I do is that I will equate the h So what is the h that I am getting from the first equation? Because it is minus h. So from equation 1 I am getting the h as minus ut1 plus half gt1 square. And from equation 2 the same h is ut2 plus half gt2 square. So do the side change and take u common. So ut2 plus t1 is equal to half g t1 square minus t2 square. So I took this term on the RHS and this term on the LHS. So a square minus b square form I am getting. So this is coming as g by 2 t1 plus t2 into t1 minus t2. So t1 plus t2 and t1 plus t2 cancels out. This gives me u, small u is equal to, u is coming as g into t1 minus t2 whole divided by 2, right? I cancelled t2 plus t1 and t1 plus t2. So now I need to calculate that capital T. So what I am going to do is that, let me just erase this part. I'll put the value of u that I calculated from here either in equation 1 or in equation 2. Whichever equation you feel like, you can put this u and you get the h. So what was equation 1? Or you can go for equation 2 which I have erased here. So equation 2 was h equal to ut2 plus half g t2 square, right? Put this value of u here. So what I am getting? I am getting as g by 2 into t1 minus t2, here t2 plus half g t2 square. So you can take half g out or g by 2 out and you are getting t1 t2 minus t2 square plus t2 square. So t2 square and t2 square cancels out. So this is your h, small h. But this small h is equal to how much? From the equation 3, it is half gt square. So it is coming as half gt square, right? So cancel the half g and you are getting capital T as root under t1 into t2. So this is the solution of the first question. I hope you really liked it. Let's go for the second question. The station from where a train starts. So S is the station from where a train starts. The train starts from rest and the train moves with constant acceleration a for small t second. So the train moves with constant acceleration a for small t second. It gains a velocity 80 km per hour after this time t second. So velocity of this train is how much? The velocity of this train is 80 km per hour after the end of time small t. And then this train moves with this velocity of 80 km per hour, say from B to C for the time 3t. So what is the time taken to move from B to C? It is 3t. So for this journey SBBC, we have to calculate its average velocity or speed because the motion is unidirectional or one direction. So obviously the average velocity and the average speed will be same. So we need to calculate that. So the formula of average speed or average velocity for one directional motion is the total distance. So let us go for average speed. Okay? So average speed will be what? Total distance by total time. Now what is the distance SB? Because with constant acceleration for the time t second, that means SB distance is going to be how much? It is going to be half AT square. Now after time t, what is the velocity here at B? It is 80 km per hour. So 80 km per hour can also be written as 80. V is equal to u plus 80, u is 0. So V is equal to 80. So with this velocity of 80, which the train gains after time t second, it moves for time 3t. So here multiply this with time 3t. So what I'm getting here is, what I'm using here is A is equal to Vt. V is 80 and for the time 3t it has moved. So that is the distance B to C. Now this is the numerator is the total distance divided by the denominator, which is the total time. What is the total time? It is 3t plus t, t and then 3t. This will give me the average velocity. So now here half at square, so what I can write, half at into t plus at into 3t whole divided by 4t, right? This 80 and this 80 is how much? It is 80. So what I am getting? I am getting as here 80, 8, 0, 80 is multiplied, 4 and 2 becomes 8, here is t, t cancels out, plus here again this is 80 into 3t divided by 4t, t cancels out, 4 and 80 is 20, so 20 into 3 is 60 and here 8 and 10 is 10, so 60 plus 10, the answer is 70. So the average velocity is 70 km per hour. So I hope you liked these two questions. Thank you for watching. I'll solve more such questions with concepts in the next video. Tata for the time.